All right, well, that was nice. We got carbs, carbohydrates. We got all them sugars that's going to give you the energy. Now we're going to step two. Step two is lipids. So the second one on the column, which is lipids right there, that's what we're moving on to now. Lipids are interesting because lipids are the weird ones that do funny things with water. Like a lot of your projects had some lipidy kind of things in it, like a wax or oil and stuff like that. Lipids are funny because they're non-polar. Okay? And a non-polar substance doesn't work well with polar substances. For instance, if I have a water molecule, let me go back to my blue. If I have a water molecule and a water molecule comes anywhere near wax or oil, okay, you kind of know what happens. I'm sure that you've seen this before. It's like oil and vinegar, right? The water's like, no, I want nothing to do with oil. I'm going to run over here. So they don't mix. Lipids don't mix water. Another word for that is they're not soluble with water. So what we're going to do is we're going to talk a little bit about that column. Let's go into the lipids column. There are two main monomers for a lipid. It's really kind of the only one that's got like two big pieces. Now the other one, nucleic acids do too. They have three. But lipids are the one that's got two things going on here. One of the things that a lipid has going on here is a thing called glycerol. Okay, it's weird that I put it that way, but it is what it is. We'll see why in a little bit later. I'll switch it around. But this thing is called glycerol. That's the molecule. Basically what a glycerol is a whole bunch of carbons bonded to each other with some more hydrogens bonded to it. There's an oxygen involved in there with a double bond, but we'll just stick with the fact that it's called glycerol. Now, so monomer number one for a lipid is a glycerol. Then we have things called, and it's one of my favorite words in all of biology, this right here, not because, this is going to be a meme now, isn't it? We get it, I know. This here stands for fatty acid tails. It's not what you're thinking. But it is. Lipids are fats. So there we go. This is called a fatty acid tail. And that's one of my favorite words about, ooh, look at that fatty acid tail. Okay, so here is a thing called a fatty acid tail. And the fatty acid tail is going to bond to the glycerol. Okay? It depends on which type of fat or which type of lipid we have. Sometimes lipids only have two fatty acid tails. An example of that is a phospholipid. A lot of times I like to draw phospholipids like this, with a circle and got the two squiggly lines that come like this. You'll see why both the circle and the squiggly lines, but it's the same thing. It's a lipid, and it looks very much like this. Sometimes there's just two of them. Sometimes there's three fatty acid tails, okay? So there's an example of a lipid with three fatty acid tails, and when you think of fat, that's what you're looking at, okay? So this guy right here, and I don't like doing that. I like doing it this way. I like it to look like the letter E. There we go. I'm gonna do that right there, do right there, put that right there. There we go. There's my letter E. That's what a real fat molecule looks like. Okay. Now, the deal with fat, we get a little bit of energy from fat. Not a whole lot of energy. We get more energy from a carbohydrate, but this is a long-term storage for energy. Okay. If I'm eating something and I need to hold on to that energy for a long period of time because I don't know when I'm going to eat again, then I'm going to store it as fat. Okay. This is the molecule that's going to take those carbohydrates and go, well, I guess we're not using these. Pump them into here and let's use this as a fat molecule. Again, the glycerol and the three fatty acid tails. Sometimes the fatty acid tails, they don't have enough hydrogen. Okay? If they don't have enough hydrogen, they're called unsaturated fatty acid tails. This is saturated. There's also unsaturated fatty acid tails. If it doesn't have enough hydrogen, then what happens is they start double bonding. And if they start double bonding in there, what happens is the chain isn't this nice straight chain. It gets all kinky. That's a kinky chain. It's like kinky boots, but never mind. It's a kinky chain, and so what happens is they have all these bends and stuff in it. So what now happens is my nice straight fatty acid tail no longer is a nice straight fatty acid tail, and I got all these bends and kinks in it. Okay, this is called an unsaturated fatty acid. Okay, the unsaturated fatty acid. The thing that's good about an unsaturated fatty acid is they don't stack. They're not good at stacking on top of each other. So if you can't do stacks on stacks on stacks on stacks on stacks, what happens is these guys kind of float around and they get burnt quicker, which is why unsaturated fats are better for you than saturated fats. If I were to take this guy off right here and put this one back on, I could take more of them, stack, 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 stack. And the more and more I stack, the harder it is to break them down. And if they're hard to break down, it could take months before these guys are burnt off and taken care of. All right? Whereas an unsaturated fatty acid tail, it's going to burn off way, way quicker. So when you're looking at your food facts, if you're trying to figure out what types of food that you should eat, look at the fat content. If it says saturated fat, you want to stay away from the saturated fat. You want to get closer to these unsaturated fats. These are the much better things for you. Like avocados have a lot of unsaturated fat in it, and peanuts and stuff like that, they have a lot of unsaturated fat in it. So that's what you're going to use. That's what's going to take care of that. So as far as your list is concerned for lipids, a couple of examples. First of all, we have the glycerol. That's what this word says right here. Glycerol. Okay, this is all, again, this is part of a monomer. So one of the monomers is glycerol. The other monomer here is fatty acid tails. Yeah, fatty acid tails. Okay. Then we have the polymers. So there are different kind of polymers. Like I said, this one here is an unsaturated. That's an unsaturated fat. Okay. We also had saturated fats. All right. Same thing with the elements that are involved. You got a bunch of carbons in here. The carbons are bonded to hydrogens. There's also oxygens. So again, the carbons, the hydrogens, and the oxygens, those are the elements that are involved. Examples of these, a phospholipid, like I said before, this guy. Oh, that's the bell. It's time to go. Okay, a phospholipid is a type. Can I spell that? Phospholipid. I'm trying to rush. PID. Okay, a phospholipid is an example of one. Fats, oils, those are all examples. And finally, the last thing that we're going to do for this is that this is a long-term energy store. Okay, so good. Thank you. See you later.